Hello everyone, my name is Fransiscus Fery Setiadi and you can call me Fery. And today I want to present about my research is the detection of DOS attack using knife-based method based on Internet of Things or IoT. The first, I will explain about IDS. IDS, or we can call intrusion detection system, is the process of analyzing and monitoring to detect signs of security problems. IDS have a function for get the data traffic is dangerous, secure, or indicated. And then I will explain about DOS. DOS, or can call denial of service, is one of the attack carried out through computer network. DOS is a type of attack on a computer or server in the network that makes the computer unable to perform its function properly and correctly by consuming the resources owned by the computer. And in this research, I will use knife bias for the method. Internet of Things or IoT IoT become the quite familiar in recent years. The number of everyday routine devices increasingly connected to the internet, which include many capabilities such as sensing, autonomy, and contextual awareness. The connection network in IoT can connect various objects that have identities and IP address, so they can communicate with each other and exchange data information. In this research, I will use Raspberry Pi for the IDS and get the detection for DOS attack. For that, I will explain my research about detection of DOS attack using knife bias method based on IoT. In this research, I will use dataset training with NSLKDD, and I will use the KDD 99 format. This format have a 41 attribute and have a 1 label. I will use two snort for the help Raspberry Pi for as a node IDS. And then the first I will get the preparation for hardware. Because I will simulate the attack, so I will get the first with the preparation hardware, which is have a router, switch, PC taker, and Raspberry Pi as IDS. And then we will go to the simulated attack, which is have actual data and anomaly data. With the actual data we get from the Raspberry Pi as idle mode, or we can try to browsing and that anything. And the actual data anomaly we get from simulated attack from PC attacker will attack a Raspberry Pi as IDS. So get the packet capture the traffic data, and the packet capture of traffic data will be extracted to the KDD 99 format. After we get the simulated attack, we get the data testing. On the data testing, you can see our data testing. We get the data anomaly and data anomaly like that. And for data training, we got from NSLKDD full dataset training. Have a many dataset training 125,973 data training like that, and that's data normal and data anomaly. After that, we can implement knife bias. On the knife bias method, we can implement the first we solve the filter selection. Will we ask the filter selection? This research is from information gain and CFS subset eval. Information gain and CFS have a feature selection method and get the 9 feature that's SRC byte, the SD bytes of 0 red, and that's all. And then we got the counting class probability. Counting class probability, in this case, research have a 2 class probability. That's normal and anomaly. And after counting class probability, we will go to counting conditional probability. Conditional probability have a 2 data type for conditional probability. The first is conditional probability with discrete data. If the discrete data, we can counting with Bayes equation like normally. But if a conditional probability continuous data, we will remodel the data with the Gaussian function. But first we get the counting mean value and counting standard deviation value for the counting Gaussian function. After we counting Gaussian function, we can get the conditional probability value. And then the final is we can choose the max score from probability. The biggest score will be predicted the data. The result, we can see the table confusion matrix like this. We get the true positive in the 1366 true positive data and false positive on the 9th value, and false negative is 1756 and the true negative is 1775 value data on true negative. In this confusion matrix, we can get the recall, precision, error rate, and accuracy table like this. In this show that the training data only fulfills half of the request data. You can see on the precision only 50.27% we get the precision data. But if it is seen from the recall result, which is so 99.50%, it explains that the method used can classify the data very well. However, it has a weakness in the low accuracy at 64.2% to the result of the study using a different dataset between training data using NSLKDD and testing data from IoT device, which is have a different characteristic for the dataset. The conclusion, based on the research result, the conclusion obtained from this study are this system is designed using naive Bayes method, in which this method uses the predict class attribute normal or anomaly. The dataset uses a training dataset from NSLKDD with a KDD99 format, which is widely used in various studies, and data testing is obtained from the IoT device packet capture on the Raspberry Pi device. Referring the result of DOS attack detection using the naive Bayes method on the IoT device, the table shows an accurate result of 64.2%. Okay, thank you for your attention. If you have a question, don't hesitate to contact me. Thank you.